Good afternoon, guys. This is Dr. Ray Science. Now, the question is this: a string supports a solid object of mass 0.81 kilograms, totally immersed in a liquid of density 800 kilograms per meter cube. Calculate the tension in the string if the density of iron is 8,000 kilograms per meter cube. And we are advised to take the value of G as 10 meters per second squared. Now let's see how we can interpret this question and answer it. Okay, one of the first things to do is write out the values given to you. Object mass, that means the iron. Let me use M naught to be 0.8. Oh, this is too small. Object mass, let me use M naught, 0.81 kilogram. Object density equal to 8,000 kilogram per meter cube. Now, object volume is mass over density, which is 0.81 over 8,000. Because from the question we are told the density of iron is 8,000, so that's what we're using here. Object volume will be 1.0125 times 10 raised to the power minus 4 meter cube. Now we need to find object weight. Let's say W subscript 0, that is M naught multiplied by G. So object is 0.81 is the mass of the object times this. So object weight is 8.1 Newton. Okay, now we have some values. Okay, now how do we understand what to do about this? So imagine there is a support here, and here is a container containing a liquid. Now this was the height of the liquid inside here. Okay, now if you bring this iron object, if you lower it into this liquid in the container, you expect the height of the liquid to rise, because there will be additional matter occupying this environment. Of course, water particles are there already. For this one to join, the volume will go up. Now, how do we know by how much will the volume rise as a result of this object coming in? One of the easier ways is to make an opening here from the height of the liquid and put extra container down here to collect whatever liquid that comes out when we lower the solid inside the liquid. Okay, when you lower this, the volume of this solid will move an amount of liquid here that will have the same volume as itself out. They follow here, come this way, and we can find out how much liquid was displaced out of this place, so that this solid object can occupy that volume. It means for this to work, volume of object must be equal to volume of liquid displaced, because we are going to use that along the line. Now, how many forces are acting here? Of course, this is a thread. There is a tension force acting through the thread up. Now, there is weight of this object acting down. Of course, there is upthrust, which is the upward force that pushes on objects immersed in a fluid. Of course, its direction is upward as well. So you watch here, there are two forces acting up, the tension up and the upthrust up. and only one force is acting down, which is weight of the object. So it's easy to say at equilibrium, total forces acting up, which is tension plus up thrust, must be equal to the weight of the object. Now, we're looking for this tension. We have the weight of object calculated. The next thing is, how do we find the value of up thrust? So I will clean this. You see, up thrust is density of liquid multiplied by volume of liquid displaced multiplied by acceleration due to gravity. But if you don't have the volume of liquid displaced, know that it is the same thing as volume of the object that was immersed, because for a lot of flotation to hold, the object must displace its own volume. So we can say up thrust is density of liquid, volume of object immersed multiplied by gravity. So we can put all of this together. Volume of liquid is 800. Volume of object is 1.0125 times 10 raised to the power minus 4. Then times 10. So we have up thrust. If you press that in your calculator, you have 0.81 Newton. So of the three forces, we have weight of object, up thrust, and it's easy right now for us to find the value of tension. Of course, from our diagram, we know total upward force has to be equal to total downward force. That means forces up must be equal to forces down. So how many forces were acting up? Tension and up thrust. How many forces were acting down? Only weight of the object. So since we're looking for tension T, we make it subject of the formula. That has to be weight of object minus up thrust. At this moment, it's easy for us to substitute. We had weight of object as 8.1 Newton minus up thrust at 0.81 Newton. So that leaves us with tension as 7.29 Newton. Malam, I hope this is clear.